Assalamu alaikum. The next topic is improper integrals. What are improper integrals? These are integrals where one or both values, both the limits are equal to infinity. How do we solve that? We know that one of the limits or the given limit will approach to infinity. So whichever limit will approach to infinity, we are going to replace this with an alphabet. Can be A, B, C, W, X, Y, Z, any value. Not the X because X is inside the function. So we will usually replace it by a T. Let's have a look at the question. This is the question. 1 upon x squared dx, show that it has a finite value. Find that value. Finite value means there will not be a 0 in the denominator and there will not be an infinity value despite the limit being infinity. So let's start. T1 x to the power minus 2 dx. Let's integrate it. Minus 1 upon x, limits t and 1. So we have minus 1 upon t plus 1 upon 1, because when we subtract the lower limit, this already has a minus, it becomes plus. So we all know that t approaches infinity as it's given. 1 upon 0 is equals to infinity and 1 upon infinity is equals to 0. In place of t, let's apply infinity. So we have 1 upon infinity plus 1, which is equals to 0 plus 1. Therefore, the value is 1, which is a finite value. Let's have a look at another question. Function is defined by this. Find fx, integral of fx. So we write t1 2 into x plus 2 to the power minus 2. Let's integrate it. 2 minus 2 upon x plus 2, limits t and 1. Let's apply the limits. Minus 2 upon t plus 2 plus 2 upon 1 plus 2, which is 3. We know that t approaches infinity. So if anything is added to an infinitely large number, the addition is extremely insignificant and that number itself becomes infinity, part of infinity. So this in reality looks like 2 upon infinity plus 2 upon 3. Anything multiplied with infinity becomes infinity. Anything divided by infinity does not become infinity, it becomes something else. As we know that 1 upon 0 is infinity, then 1 upon infinity is 0, right? So this is minus 2 into 1 upon infinity plus 2 upon 3. 1 upon infinity is 0, so this becomes 0, and the answer, final answer, is 2 upon 3. Other kinds of questions that we can get for improper integrals are like this. Find the value if it exists. We can see that one of the values is 0. An improper integral does not exist if it diverges to infinity, because the integrand, or this which is being integrated, has an infinite discontinuity at the lower limit of integration, which is 0. How do we do that? Let's have a look at it. So the question says 5 upon x square. Let's write it in a usable form. The function is undefined when x is equals to 0, because x is equals to 0 in the denominator makes it undefined. Therefore, x is approaching infinity. When x is approaching infinity, fx is also approaching infinity, or the entire function is also approaching infinity. In this one, we replace this limit 0 by an alphabet such as t, and in the previous questions, we were replacing infinity by t. So we will write 2t 5x to the power minus 2 dx. Let's integrate it. When we integrate it, this becomes minus 5 upon x. Limits are 2 and t. Let's apply the limits. This becomes minus 5 upon 2 plus 5 upon t. We know that t is approaching 0. It means that it is some number which is very, very, very close to 0. For example, 0.0000432, anything, right? Extremely small number. So 5 divided by an extremely small number grows infinitely large. When it grows infinitely large, it approaches infinity. So this becomes minus 5 upon 2 plus infinity. So anything added to infinity is also infinity. So the conclusion is, since the limit equals infinity, the integral is diverging. A finite value of this function does not exist. Next question. The diagram shows part of the curve this. Show that as p approaches 2, the shaded region tends to a finite value, and find this value. To show that the shaded area tends to a finite value as p approaches 2, we evaluate the definite integral of the function from 0 to x is equals to p first, and then we take the limit. What do I mean by this? Let's have a look. First, let's bring the function in a workable form. 3 into 2 minus x to the power minus half. We have limits 0 and p. So the upper limit is p, lower limit is 0. Let's integrate it. This becomes 6 under root 2 minus x upon minus 1, because differential of this expression. So this is minus 6 here. The limits that we have are p and 0. So we have minus 6 under root 2 minus p plus 6 under root 2 minus 0 is under root 2. Now, the question says p approaches 2. As p approaches 2, it means it becomes extremely close to 2, which means 1.9876, something like this, extremely close to 2 if it's not exactly 2. So when p approaches 2, it becomes dangerously close to 2. So a number very close to 2 subtracted from 2 is almost equal to 0. So 2 minus p will approach 0. So this term becomes 0. 0 plus 6 root 2. Our answer here is 6 root 2. That's the answer. So as p approaches 2, the shaded area tends to a finite value. That finite value will be 6 root 2, or approximately, if we put it in the calculator, it will turn out to be 8.49.